Hi everyone, welcome back to another continuous time problem, and today our goal is to solve for problem set 6.1, where our goal is to find our frequency response, our impulse response, and then our output y sub t when we are given a certain input. So in order to solve for this problem, we are going to use our game plan. We're going to use our Fourier transform to solve for our frequency response for part A. And then since we have our part A, we can use the table to solve for our impulse response. And then from then on to solve for part C, since we know that convolution in time is multiplication in frequency, we can then be able to solve for our y sub t using some partial fraction methods. So we're going to get straight into it. For part A, as you can see, I changed from time to frequency to make things easier to do. And then from then on, by just using simple algebra, we can then solve for our frequency response h of j omega. For part B, we get our frequency response from part A, so all we're going to use the table to solve for our impulse response h of t. So it's just as simple as that, and we're actually going to be using this process again later on. For part C, we have our x of t. This was a given. What we're going to do is change our x of t from time to frequency, and then use that as part of the multiplication in frequency. As you can see, this is exactly what I did to then be able to get our partial fraction, where our goal is to solve for our a and b values. As you can see, my a values were a is equal to -2, and my b value is b is equal to 2. From then on, you can plug back the a and b values back into your partial fraction to then have our y sub t in frequency for y sub j omega. From then on, you're going to change back into our time domain from frequency to time, the same way that we solve for our impulse response. And just like that, we are able to find our output y sub t, which is this function right here. Thank you, and come again, please.